Okay, so if you already understand composite functions, I want to do a quick video about decomposing functions. It's just a pattern recognition. And there's one extra bit of instructions I like to write down because technically there's a silly answer that's always, well, it's always technically a correct answer, but it goes against the spirit of the question, and I want to rule that out. So let me talk about what I want and what I don't want. Oops. There's an M in the word composition. So write h of x as a composition f of g. So first of all, let h of x equal, well, let me just make something up. All right, so there's more than one way to do this, and one of the first things that might stick out is, well, the inside function is what do you look at where x is, and then what's the first thing that happens immediately on the very inside, and then you do more things after that. So maybe g of x, I want to simplify it, but every time I replace that I see x minus 1. That's pretty meaningful. So on the instructions for the homework that I give, I'm a little bit paranoid here, but this is already, it's not, you're actually doing something here. So it's kind of, you're breaking it into parts. It's like, yeah, the inside of that parentheses is x minus 1. So that's a very useful thing to look at maybe. So then, so what do we do to x minus 1? Well, we square it. Well, we square it, we multiply by 2, and then we add 3. So let's sort of verify, well, there's the inside function. What do we do to it? We square it, we multiply by 2, and then we add 3. So it's like, what do we have? We've got this inside function. So we take f of x minus 1, so it's not just x squared anymore, it's x minus 1 squared, but then yeah, twice that plus 3. And we're pretty happy here. So that's a pretty good solution. You can do yeah, you can do other things too. So that's like solution 1, solution 2. Well, maybe, I don't know, maybe x minus and the lack of with the lack of more clear idea of what we actually are looking for. Well, let's just take anything that's kind of useful here. So well, if we're grouping it a little bit differently, instead of just taking x minus 1, let's take this whole thing as our first building block. And then what do we do with that? We take, now the outside function is this linear function. We take twice this thing, because the squared is, incorporate that into the inside function. That's totally fine. If I did it this way, well, let's sort of check. So it's f of x minus 1 squared. So we get x minus 1 squared. So f, that is playing the role of the input, but what do we do? F takes twice of the input and adds 3. And So is this h of x in both cases? So those are all perfectly valid. So what is? So the only thing is, I claim that you can go to one extreme or the other, and it's kind of very, very silly. And here's something that's not meaningful. So let's say h of x is equal to well, here's something that you can always do. So if I let g of x be equal to x, and I let the outside function be just the whole thing, well, this is kind of dumb, but it's like, well, f of g of x is f of x, which is just, well, the inside function takes x and it gives you x again. And then what happens when I take f of x? Well, that's the whole thing. And but the whole point is it's not well, just to pick a word, it's sort of, it doesn't actually do anything. So it's perfect. It's mathematically correct, but it's sort of it goes against the spirit of what we're trying to do. If you ever go on to Calculus 1, you'll be extremely motivated to, like, there are certain ways of decomposing that will be useful, and you automatically pull toward that, so it won't be a big deal. It's just, well, technically, the way the problems are written in the book, you could always write this down. You could always write the inside function as g of x is equal to x, and it's technically, yeah, you wrote that as a composition of two functions, but you just did a really silly, not very natural, not very useful. The whole point is you want to break it into two simpler parts that, well, the relationship is that there's an inside function and there's an outside function, and they're actually working together. It's not just something completely silly and trivial. The other one is the outside function. If the outside function just takes the input and returns x again, then exactly the same thing happens for similar reasons, but I just want to show you that if one of the two functions basically just takes the input and just leaves it completely alone, it just keeps going on the conveyor belt and completely unchanged, you get the same thing again. Okay, so, well, the inside function is all of this stuff here, blah, blah, blah. The outside function, what does it do? You plug this whole expression into the input, and then it returns exactly the same thing. F is so almost any instructor, whether they point this out to you or not, it's, well, you kind of have to be clever to see that this is a possibility. But if you do turn this in, almost any instructor is going to be like, okay, wise guy, that's not the point of the exercise. You're being silly. That's not what I actually want. It's just, no matter what your function is, you can always let one of the two functions just be the original function itself, and then the other function could just be that function returns x, and then it's technically possible, but it's kind of, it's completely pointless, and it goes against the spirit of what we're actually trying to do. So if I say meaningful, that means I don't want to see this. anything that's completely irrelevant. Like I could let g of x be x plus 1, and then f of x would have to do something stupid, like you would have to you would have to subtract, you'd have to subtract 2 to make up for adding a plus 1 for no reason. So there's lots of stupid things that you could also do that are like not useful. But all the good things to do should sort of jump out at you. So it's kind of, you just go to, you have like parentheses, and you go to the very inside, and you take something real nice like this, or maybe this. Just kind of what's the innermost thing that sort of follows a pattern that sort of is going to be very, very helpful. And then break the function into nice little pieces. There might be more than one correct choice, and there'll all be things that are right there on the page that look nice. And that's all we're really looking for here. This is clever, but against the spirit of the exercise, and it's not what I want to see. So that's it.